Hey there, hope you're doing good. As we continue refactoring Futurecam, we found two similar functions. One is called verify full resolution and the other is called verify reasonable resolution. Verify reasonable resolution ensures that the width and height is greater than the minimum. So we have a minimum value that applies across all modes, light trail, time lapse, burst, etc. So it has to be more than the minimum width and the minimum height and less than the maximum. Of course, someday if Apple releases a 20 megapixel camera, this code will break, but that's okay. It hasn't happened in what, 7 years? So I don't think we need this verify full resolution function. And verify full resolution, just to complete what I was saying, verifies that the capture is happening at the full resolution of the device. So the first thing is, do we need both of these? The reason we have to take the device as a parameter is that the front camera, at least on older iPhones that the app supports, has lower resolution. So you can't just say 4032 by 3024, which is 12 megapixel, which is the normal resolution of any of the 3 back cameras. That doesn't work for the front, unfortunately. The other reason I am a little uncomfortable with this code is you are accessing the device's resolution, which in turn goes through our code. So if our code is bad, the photo or video will be captured at the wrong resolution, and this function also will not detect it because it is using the same API. So this is something we need to figure out what to do. And where is this used? Burst saver uses it. Okay, so in this case, burst uses only tele. So we should verify that it is 4032 by 3024. This is something we need to work on. The other place where verify full resolution is used is in frame producer. I see. So one step is, let's try to de-abstract this out. I used to have a spreadsheet. So here's one way I can do it. If it is not the front camera, Apple has this huge table of AV captured device format resolution, this one. in typical Apple style, they are not linked. There was an old documentation somewhere which hasn't been updated even when I was working on Futurecam 2.5 years back. This is the one. See, documentation archive. This was last updated in 2017. So Apple often deprecates documentations without creating updated documentation. See, this ends with iPhone X. After that we have had XS, then 11, then 12, then 13, now I think 14. So these are the detailed tables I'm looking for. So how can developers build apps without proper documentation? Okay, so this is what I remember. The front camera goes to some lower resolution like this. And I don't know why we call verify reasonable resolution. This should be 12 megapixel. This should be 12 megapixel. So let's do this. Let's go through the only situation where you have less than 12 megapixel is the front camera, which is used only by time-lapse mode, which produces a video. So anytime you're saving a photo like this, or you're working with a photo, it should be 12 megapixels. So let's rename this. Let's not have two generic functions. Verify 12 MP. Like, what's reasonable? What's full? Let's not have these vague terms. And maybe the time-lapse mode should not call this. Now you don't need to log the expected values. Did I get this right? Yes, 4032 3024. If you multiply that, you get 12 megapixel. And this doesn't need to call verify reasonable resolution because we are doing that here anyway. Which means we don't need the AV capture device anymore because we are not dynamically checking its properties. Okay. Now we need to find the callers of verify full resolution and change them. I was always uncomfortable about passing the device into a verify statement because that implies the verify is too smart. So if you have some actual code and you have some checking code, and both of them use the same underlying API which you have built, or for that matter that Apple has built, they are also buggy. Then if there's a bug in the underlying API, the verification won't trigger. So the verification should not be smart, it should be dumb. It should have a hard-coded value like this. So that anyone can know immediately whether it works or not. If you look at the earlier code, I couldn't look at this code and tell you for sure that it works, which means this code is not useful. Don't write such code that you yourself in your heart don't trust. Like you think it should work, but you can't say with 100% certainty. This I know will work. There is no way comparison with 4032 can fail. Okay, so where are we? We can do it in the mode photo output. Because each mode knows whether it can or cannot verify full resolution. The burst saver can verify it for the burst mode. Buffer.save. What's this? Is this an copy next sample buffer? Sorry for my alarm going off. So here dot save. This can verify that it is full resolution. Can it or can it not? Yeah, so burst, hold on. If we are capturing from the front camera, we are going to assemble them into a video like we discussed. Yeah, so this can verify. So instead of doing it here, put it downstream. So this ultimately just calls CV pixel buffer or CG image. So let's put it in the lowermost layer just before we save it to the photo library. CV pixel buffer. What? We don't have a CV pixel buffer dot save? Oh, maybe it's in some other file. Oh, same file. Okay, CV pixel buffer again delegates to CG image. So here we can go to CV pixel buffer, which again goes to CG image, or we can go to CG image. So let's look directly at CG image. CG stands for core graphics. Yeah, this is where you're actually creating a data which is like a byte array and using the iOS APIs to encode it. I wish there was some code that detects commented code. Oops. Verify 12 MP. In general, verification code, like I said, should not be abstracted out, both the implementation as well as the name. This name says verify 12 megapixels. So now I know what to expect when I call this and when I should and should not call. Whereas if you say verify full resolution, people have to think, what does full resolution mean? Does it mean the highest among all the 4 cameras? If so, it won't be all 4 cameras won't achieve the full resolution. Or does it mean for a camera, one of the 4? Or does it mean the highest among the back 3, which is 12 megapixel? Like, what does full mean? So keep it simple so that it's obvious. Here there's a save which does not need this check because it is ultimately calling CG image. So all the save paths go to CG image. If you can start with an AV capture photo or with a CM sample buffer. From there you go to CV pixel buffer. Let me see if I can draw this somehow. This kind of big picture is very easy to lose. AV capture photo or CM sample buffer. How do you draw a down arrow? I'll do it this way, the way we used to in school. Okay, these two go to CV pixel buffer. I should have drawn this on paper, that would be much easier. Go to CV pixel buffer, which goes to CG image, and there is also a direct path from here to CG image. Maybe I'll put it above. So you start with either of these two, then you go via CV pixel buffer to CG image or directly, and from there you go to the photo library. This is the iOS photo library. So there's no image format conversion anymore. You can also go into a loop where you can go to UI image, oops, M should be small, but then if you go to UI image, you go back to CG image. So this is just a diversion along the path, it's not a separate path. Just like CV pixel buffer is not like a new path. The path doesn't split, it's just a temporary split, it will rejoin at CG image. So if you think in terms of a road network, right, you start at either of these two places, there's a direct road to CG image, there's an indirect road that stops at an intermediate town called CV pixel buffer. But both roads go to CG image. So you know, when you're traveling from one city to another, sometimes you have bypass road that bypasses big cities to save time. So this is like a bypass road. You come here, this is like a dead end. If you come here, you can only go back and then you go here. So anyway, this is the inheritance hierarchy. This should be captured and put in the code. I wish that source code is extended to allow rich text or at least images for documentation in comments. Like you don't want the entire, you don't want random rich text anywhere. But yeah, I mean, for that matter, right, just as an aside, why can't you have in code let image equal to, and you drag and drop an image here right in the code rather than storing it in the file and storing it in the bundle and accessing via path. Anyway, so unfortunately, because of the lack of tooling, we'll have to delete this Google Sheet. There's no place to put it in the code. Actually, there's something I could have done. I can take a photo and upload it to GitHub. Let me try doing that. So, actually, instead of a screenshot, which would be non-editable, if I download as, I can't download as a text file. As a HTML, no. Spreadsheet. Okay, never mind, I'll just delete this. In a real code, you should actually save this documentation in a real project. So yes, so basically, if you look at the diffs, the burst saver does not need to verify anything. Frame producer does not need to verify anything. CG image is the only path that verifies, and it verifies full resolution. See, earlier we weren't sure which path is taking which resolution photos as input, photos or videos. Now we have thought it through. So now we are able to put in a stronger guarantee at exactly the right place instead of randomly sprinkling at 3-4 places. So I'm happy about this. Let's go to regex mode, verify dot star resolution. Liquid shutter controller. Yeah, this again goes to the same code. So actually, I'll think, let me rethink something. When you have a flow where function A invokes B, invokes C, invokes D, invokes E, you can and should verify that E is getting the correct input data, because that amounts to verifying A, B, C, D, all 4 of them. And it amounts to verifying all the paths. A may invoke C directly in some cases by passing B. If you put a verification or a check in E, it is covering all these cases. Maybe B sometimes bypasses C, so you can have a very complex graph. Ultimately, the graph ends at E, but before that you can have a very complex graph. And this entire graph will be verified by a verification in E. However, it's also good to detect things early. So that way, if things are bad, it's easier to pinpoint where the problem is. So let's not detect, because I did spend a lot of time struggling with this. So let's not throw away the work. Because there are a whole set of classes that work together here. Here we can't do it because this is common for all cameras, like front camera. This should be able to verify it. The reason I am putting this here is, otherwise when this verification fails, sometimes we don't get a stack trace, so we don't know which of the callers of verify full resolution has suffered this problem. So we need to do this. So let's look at it again. There are some more changes to make, but let's look at what we have until now. This function is renamed. This verification is actually unrelated, except that it gives you some more guidance. It pinpoints a specific problem. So what if you get 3024 by 4032? This will detect it. But in iOS, sometimes it's possible to configure the camera to rotate the buffers and give them to you. You shouldn't do that because it takes a lot of resources, because you're processing 36 or 48 bytes of data for every frame and 30 frames. So that's like a gigabyte of data that's being processed. So it's basically iterating through the image, exchanging rows for columns, pixel by pixel. You shouldn't do that. That's like a waste of resources. So this detects this. We had a Google Doc in my earlier G Suite account, or Google Workplace, Workspace, whatever they call it, that account. When I shut down the company, I deleted that account. So this Google Docs link is bad. Let's see if we can find a better link. Yes. If you find a broken link, update it. Like no one else is going to do it if not you. This is the owner mentality. Even if you are an employee, tend to your code. If it's like a car, don't just drive the car, clean the car, maintain the car. The way you do with your own car. So in the burst saver, burst uses telephoto mode, telephoto camera only, so it should be 12. In the frame producer, you can't detect it because you don't know what resolution it is. In the liquid shutter controller, yeah, this is again full resolution. Oh, we need to look at this. This is not video burst saver, this is burst saver. We need to look at this second arguments as well to make sure they are descriptive. Or have I lazily copy pasted? This doesn't need a width and height, it needs a color. Oh, we need to check the arguments as well. Oh my god, I keep forgetting. We don't need a device. We don't need a width and height, we only need this. And does it have a keyword? It should have a keyword. So in Swift, if you have a function like whatever, right, drive, destination, string. Suppose you have a function like this. When you invoke it, you are supposed to invoke it this way. Destination Chennai. On the other hand, if you call it, if you put a underscore here, then you are not supposed to use this keyword. You are supposed to invoke it this way. And the compiler is particular in both cases. If you are supposed to invoke it like this, you can't invoke it like this, and vice versa. So now it's a question of readability. If I just say drive Chennai, this is clearer. drive destination Chennai. Now suppose you have via an intermediate city, Coimbatore or Vellore. Vellore would be an intermediate city on the way from Bangalore to Chennai. Now it's clear which is which. Otherwise, if you just say drive Chennai, Vellore, what does it mean? Does it mean first you go to Chennai, then you go to Vellore? Does it mean you need to reach either of these cities? So keyword arguments are clearer. So in this case, when you look at a call site, if I just look at it this way, this is not clear. What is this string? You are verifying the resolution of the string. What are you doing? No, this string identifies the caller. So it should be like this. So write the code first, then fix the definition. Not the other way around. So evaluate code by the call site. Now that I have written this code, I know I need to do it this way, not this. Okay, let's go back to our search. This is there's no full resolution, verify 12 MP. This is one of the advantages of iPhone over Android, which is there's less fragmentation. You are creating a UI image only to display. Let's see where this is invoked. We need to look at this. Yeah, it is used only for. Oh, you're not using it. Okay, fine. It's used only in the liquid shutter controller. So this can be verify 12 MP. Great. Now we don't have this function anymore because we have tightened the rule. We don't need to. This takes only a caller. The caller is burst saver. You can just see here itself. This matches this. The caller matches this. The caller is cgimage.save. The caller is the initializer which takes this. As engineers, we can't leave unbalanced brackets, can we? This is UI image.save. Great. And are these the same diffs? This function is removed. Removing code is always good. This empty if statement is removed. Now the only thing we have lost is this verify reasonable resolution. This should be taken care of in the time-lapse mode, because the frame producer is invoked by the time-lapse mode, and when we remove this, I don't even know how we are verifying full resolution. We need to verify reasonable resolution here, otherwise this will fail. Is there another call to verify reasonable resolution? No, this is strange. Is it in the frame blender? No, the time-lapse mode doesn't invoke the frame blender. Oops. Frame blender. Here also we should do something. Let's see what we can do. Is there any verify reasonable? No. The time-lapse mode just captures photos and writes them out to a video file. It doesn't process them using the frame blender. So this can invoke a verify full resolution. This can have verify full resolution. MP, that's what we call it now. So this will detect a problem as early as possible, because if you have a wrong resolution photo, then you blend it, then you convert it to 3-4 formats, and then you detect the problem, then you don't know where the problem is. So the light trail mode uses this, and the light trail mode cannot ensure that it is 12 megapixel. It's not actually. Where do we do the crop? Let's see. This should be correct, but who knows? Is this my code? Yep. This should be made better. It should be something else. Okay, never mind. Let's not digress. So where are we calling replacement frame for? Here, before we replace the frame, we need to check. So the blending, is it happening at a lower resolution is the question. Yes. The cropped frame is being blended, so you can't do a check here. Actually, you can. This is invoked by whom? Let's do this. Let's undo the change to the frame blender. There's no change. Why is it still showing in the diff? VS Code diffs are unreliable. See, there's no frame blender here. Anyway, we can invoke it in long exposure mode. Long exposure mode. Oh, the frame blender is not used by the light trail video mode. This one uses the frame blender. Yeah, this is just some start recording. Oh, it's not used in light trail mode. So the frame blender can always verify that it is 12 megapixel. This is a private func which is just invoked here. So let's check it as early as possible. The frame producer is used for the front camera as well, including in time-lapse mode. So this cannot check, but this can check, the frame blender. Now this is the input, and then you add and you limit memory usage. And yeah, this is not just a frame. Oh my god, so many instance variables. And look at how many qualifiers this has: OBJC, dynamic, private, static, weak, var. Okay, never mind. Where does this give the output? Yeah, this goes to the liquid shutter controller. Oh, there's no buffer here. There's no place to call it. So I think this verify 12 MP should be available on all the data types like CG image, UI image, and so on, but that's another change, so let's not do that now. Actually, it's not a big deal. We can just access the okay, never mind. I think we're going too far. Like here, we could write a did set and verify that the photos that are set are the right resolution, but let's not do that now. Can't do this here. Yeah, UI image doesn't have a verify 12 MP function, so we can't even call this. We'll just put to do's. We spent some time figuring this out. I don't want to lose that information. So, you have figured out, you have spent a lot of time today to figure out where to put these calls. So, let's not lose that information. UI image has this, CG image has this, liquid shutter controller has this, frame producer cannot have anything, frame blender, yes, here we can have it. This is the input to the blending. Where's the output from the blending? Yes, here. Actually, the partial result callback can be low resolution. This is just to display in the UI. This is the thing that needs to be full resolution. Frame blender dot, what is this function called? Add. here we do have a buffer. So long exposure mode, so see, these are the modes, right? Long exp, light trail, time lapse, burst. These are the 4 modes in the app. Among these, light trail and time lapse don't produce full resolution images, so you can't check there. So burst, we have a change in burst saver. Here you can see where my mouse is. We have already taken care of burst. Long exposure invokes frame blender, and we have taken care of it in the frame blender. So this is taken care of. Now we need to think about light trail. The input to light trail does not use the front camera, so it has to be 12 megapixel. This is what happens when you write code in comments. Light trail video mode dot replacement frame fur. Now that takes care of light trail. Now for time lapse, we need to do something. We need to verify that it's at least the resolution of the front camera. Here for any, is anyone even using this now that it's deleted? Okay, so this check has to be put in the time lapse mode. Cannot be more than 12 megapixel, of course. So let's add some checks in time lapse mode. So if you notice, the code we have checks the maximum as well. Here it checks equal to, it doesn't check greater than equal to. So we had bugs in the code where it would take two 12 megapixel images and combine them, but they were misaligned, so the output was 20 megapixel or something. They were partially overlapping when they should be fully overlapping. So this double equal to is important. It's not just verifying that the resolution is at least 12 megapixel, it's verifying it's exactly 12 megapixel. Okay. So we need to figure out where to put it. Yeah, we can put it in the frame producer where it comes from. This code we deleted instead of in time lapse mode. Do we use BGRA? Wait, actually let's look at light trail mode first. That's something I'm more interested in. Yeah, this is what we need to do. There's a place where we save a video file. Trying to find that out. Abstract video mode. Save. This is the one. Here let's write some verifications. Actually, even the to-dos I put in the other file I need to remove. I know I am flip-flopping, but verify image dot extent dot origin dot roughly equal to 0. So the image, this is some iOS weirdness. The image, you would expect it to have a size, a width and a height, but it also has an origin. So you can shift the coordinate system, and if you get that wrong, if it is not 0, things go haywire. You need to call roughly equal to, otherwise it's a floating point comparison. I don't know whether it is this may not work in portrait mode, so that's okay. If it doesn't work, we can fix it. We can't rack our brains. The problem is iOS has a whole set of image formats, and in some of them the width and height change based on the orientation, so they can get interchanged. In some of them they won't, because it's in the metadata. So never mind, we'll just write this code. In a way, putting to-dos is laziness. Oh, that's just the highlighting code. Yes. If you are not sure about putting a verification, put it in. If it triggers, you can always fix it. So I'm not obsessing about, should I write code that says the higher among the two is 4032 and the lower is 3024. So like one of them should match 4032 and the other should match 3024. Should I write that code or should I write this code? Will this work in portrait mode? I'm not obsessing about it. I don't know. If the verification fails and at runtime you see that they're interchanged, you can fix it. Yeah, in this file we need to do something. This is what? Non-real-time video writer dot append frame. Okay, never mind. Let's not mess with the diff. Oh my god, this refactoring is never ending. Huh? Okay, so we have changed this code. Then burst saver, we are verifying. Frame blender, you have a result. Checking the origin. No, result dot extent. It's an image. You can't do image dot width here. You should have a helper function for this, but that's a different conversation. Oh, this works because verify full resolution takes care of the front camera, the complex code that we had. This is on CI image, so it's fine. Screw it, I'll just do it the right way. Sometimes the lazy way is more work. In Telugu there is a saying Baddakishtiki rendintalu pani or something, which means a lazy person ends up doing double the work. Let's forget this caller. Let's just make it simple. So in CI image you now have verify 12 MP. You're verifying that the extent, you don't need to do image dot because this is within the CI image. You are verifying that the origin is 0, width is 4032, height is 3024. Let's keep it consistent. Origin. Okay, so now that we have this function, where do we use it? UI image also needs something. We'll work on it in a while. CI image, this is the definition. CG image also needs something. What is the data type here? CI image. This can just say verify 12 MP. Non-real-time video writer. Frame producer, yeah, this we need to work on. Frame blender. Burst saver, yeah, this is fine. Actually, for consistency, I'll even remove the caller. This does not trigger actually in production. So we are just like result, we just have overcomplicated code. So let me just close all these files. We'll open one by one. Let's open all of them. We'll delete each file as we'll close each tab as we are done with it to keep track of things. Here, is there anything to do? Nothing. This code has to be pasted in the frame producer, so we'll keep it. Burst saver, you don't have a caller anymore. frame producer, you have to check something, so we'll keep that. Non-real-time video, oh wait, a video writer need not be 12 MB. So here for light rail, this is the output height, so we need to check this. So here we can't call verify 12 MB. Liquid shutter controller, we can verify 12 MB. CI image saving, we can verify 12 MB. Yeah, here let's verify. CG image width and height. Okay, it has width and height which are integers. Okay, great. Verify width equal to 4032. The wrong width in CG image dot save. Height is, now you can say we should create named constants, but really 12 megapixels is not going to change. CG image is taken care of. We need to look at this as well. Let's finish it off. UI image width. This used to be a C API. In Objective-C also it was a C API. With Swift, Apple finally made it object-oriented. Like they should have done it with Objective-C itself. It's an object-oriented language. But anyway. Okay. Does this have an origin or an extent? No. UI image. How on earth do I get the size? Oh, you need to multiply it by the scale. Oh my god. Okay. Can you multiply a CG image with? Okay, fine, never mind. Let's write this code. Func verify 12 MB var w equal to size dot width times scale This is what Apple says you should do. And then you should round it. Don't know why Apple prefers floating point sizes. This can be a let, both. If I do it the other way around, I have to put one more brackets, just being lazy. Wrong width for UI image. If one of these triggers when it shouldn't, we'll take a look. Okay, so this has taken care of it. Frame producer we need to work on. Frame blender we have taken care of. We should call it long exposure blender. The input should be 12 megapixel. Frame producer we need to work on. What happened to the writer? Excuse me. Yeah, when we write a file, we can't write a 12 megapixel video file for whatever reason, so we crop it to 2056 here. So this is used by both time-lapse and light rail. This is the final output that is being written. This is correct. Now if you look at each of them, the time-lapse mode should have something. The light trail video mode, what does it check? It checks that the input is 12, yeah, and the output is finally taken care of there. Okay, great. So, oh, I think there's a mistake here. If you are writing a video produced by the front camera, it won't be 4032. These are not used anywhere. Max photo width for any is used. This is the one, 4032. So 3088 should be the one. Those named constants were MS. So the non-real-time video writer, yeah, this is also not true. To do not correct for front time lapse. This is something we need to work on. So in this one, you can't verify that it is 12 MP. This is a refactoring that is safe. So let's start from the beginning. In the frame producer, It should at least be 3088. Here you are calling process frame. Take bracket if needed. Finally capture self.process photo output, which calls process frame. There's no image processing going on, so we can go to process frame. Process frame. Does this have a width and a height, this class? We should. So let's take a step back. We have accumulated too many changes here. I am not comfortable committing 13 changes here. I'm sure I've gotten some things wrong. So here's what we'll do. We'll stop this video here. In the next video, we'll break these changes into parts and make them one by one and commit them. And we'll do that in the online version of VS Code. We'll make a bunch of changes. Once all of them are done, we'll revert all these changes in the installed version of VS Code. See you in the next video.